second series of how to of trigonometry or algebraic processes, we are going to be talking about the special angles and the ratio of the special angles. After that, we'll talking about I'll be giving a practical example. We'll be solving that example, and then finally at the end of this video, we'll be talking about how to look for the squares and the square roots of numbers using your logarithm table. So if you don't know these special angles, this is the table of special angles. Sin 0 is 0, sin 30 is 1 over 2, sin 45 is 1 over root 2, sin 60 is root 3 over 2, sin 90 is 1, cos 0 is 1, cos 30 is root 3 over 2, cos 45 is 1 over root 2, cos 60 is 1 over 2, cos 90 is 0, tan 0 is 0, tan 30 is 1 over 3, tan 45 is 1, tan 60 is root 3, and tan 90 is infinity. So I made a mistake here. Tan 30 is actually 1 over root 3, not 1 over 3. Now we are going to be using the knowledge we have gained so far from the previous episode on calculation using trigonometry. We are going to be using it to analyze this. So they said find AD in this question. So what will AD be? Now, first of all, we are going to apply the tangent. We are going to say tan theta, that's theta is 60, tan 60 is equals to opposite over adjacent. That will be AC over the adjacent is 4 centimeters. So now tan 60 is root 3 over 2. Sorry, is root 3, right? That means let's cross multiply. That means AC, length of AC will be equals to 4 root 3. So this will be 4 root 3. So moving on, we have after we have looked for AC here, we are going to use that knowledge to look for AD here. So we are going to use, instead of tan again, we are now going to use sine. So that means sine is opposite over adjacent. That will be sine. What's the angle? The angle is 45 degrees. Sine 45 equals to opposite. Opposite is 4 root 3 over adjacent. Adjacent is AD. So we are looking for AD. So by cross multiplication we have and division, we have AD equals to the length of AD. So it is denoted like this: the length of AD put in vertical lines. AD is equal to 4 root 3 all over sine 45, and sine 45 is 1 over root 2. 1 over root 2. So AD will be equal to 4 root 3 times 1 over root 2, not 1 over root 3. Sine 45 is 1 over root 2. So AD will be 4 root 3 times root 2 over 1. That would be 4 root 6. You know that whenever you multiply, so they multiply like this. That would be 4 root 6, and then we'll add our unit, which is centimeter. 4 root 6 centimeter. So that's how to use trigonometry to solve triangles, not just triangles, but right angle triangles. So now we'll move next to the next part, which is how to use your tables, your logarithm tables and your four figure tables to look for the squares and the square roots of numbers. So thank you for watching. Earlier on, we were talking about Pythagoras theorems and the solving of triangles, right? Now, in this particular section of this video, we'll be talking about how to make use of your logarithm table to look for the squares and square roots of numbers. So let's look for the square of 39.91. So you look for under this first column, you look for 39. This is 39. Then you now go under difference 7. You go down from difference 7. So 39 difference 7 is what? So the intersection is 1576. Then now go because we are looking for the square of 39.91. So we look for difference 9. That's 39.9. 9 is 1592. This is it here. So this 1592, you circle it here so as you not forget it. Then this 1592. So we are looking for the square of 39.91, right? So we'll go to difference 1. That would be 1. So we'll add that 1 to this number here. That will be 1593. So that means the square of 39. So the square of 39.91 is 1593, and you can adjust your points accordingly. So you can see that this is the square of different numbers. So square of 39.91, 1593. Then we have the square of 40 is 1600. The square of 41 is 1681. So if we're looking for the square of 45, now we'll look for 45 here. If we're looking for the square of 45.5, that will be 45 difference under 5. That will be 45 under 5. That's 2070. Now let's go on to square root. The square root of 30.1 is 30 difference 1. That is 1.735. That is how to make use of this logarithm table to look for the squares and square roots of numbers. Thank you for watching.